Hey, welcome back, Chem class. This is another set of notes. This is page 17. We're going to talk about Boyle's Law. So again, as you're hopefully taking notes in your notebook or you've got a place to specifically be taking your notes, you've kind of got the outline written down and you're ready to just kind of continue on. So for the next couple of days of notes, we're going to be talking about a couple of specific people, and then we're going to put it together in what is called the combined gas law, but that's not until next week. So just kind of moving on from here. Today we're starting off with our empirical gas laws. That means the simplest form. We're going to start with Boyle's law. He's kind of the simplest one to start with, and we've got what his says, pretty simple, is that a volume of a fixed mass of gas varies inversely with the pressure at a constant temperature. So we're keeping the same amount of gas, but we're saying that the volume varies inversely with the pressure. And that's a lot of big words for me with the inversely and all that. So I just like to keep it pretty simple here. And so what does that mean is that as the pressure goes up, the volume will go down. And that hopefully makes sense to us if we think about having a balloon and we squeeze it, so we're increasing the pressure or we're decreasing the volume, right? So if we squeeze a balloon, that pressure inside the balloon increases, and sometimes we pop the balloon. All right, so that's kind of one way to think about that. Think about squeezing a balloon, right? And we didn't change the temperature there, so that's one way to kind of look at it right there. And today we're just talking about the pressure and volume relationship, which is, it can be written in this formula, P1V1 equals P2V2. So pretty simple formula. Write it down somewhere. That's going to be something you're going to want to hold on to, this P1V1 equals P2V2. And today's problems just have to do with that as well. So if we look at our examples here, kind of rolling down the page just a little bit, we have our first example. It says a sample of oxygen has a volume of 150 milliliters when its pressure is 0.947 atm. What will the volume of the gas be at a pressure of 0.987 atm if the pressure remains constant? So what I like to do, we like to go through and break it down. So this very first one, we have a volume of 150 milliliters. So over here to the side, V, and I'm going to say V1, because that's the first volume I saw, is equal to 150 milliliters. So I'm just going to copy it just like it was. When its pressure is 0.947. So again, that's the pressure that goes along with this. So we've got P1 equals 0.947, and that's ATM. The next sentence says, what will the volume of the gas be at a certain pressure? So V2 is what we're looking for. That's our question mark. And our pressure is P2, and that's 0.987 atms. And now we're ready to just use our formula and kind of plug it in and solve. So we've got P1V1 equals P2V2. That's our formula. And now we just plug these in. So 150 times 0.947 is equal to V2 times 0.987. I kind of got out of order there, but hopefully you're okay with understanding that I put V2 first instead of P2. And now, to kind of do some algebra here, we want to get V2 by itself. We're gonna divide each side. Maybe I should change colors here so that helps us see us transitioning there. We're going to divide each side by 0.987. Divide each side by 0.987. So V2 will be equal to 150 times 0.947 and divided by 0.987. And we'll just plug that in our calculator. We're going to keep 3 sig figs in our answer. So 150 times 0.947. And then we're going to divide by 0.987. And our answer, we got 143.9297, and then, well, there was a 0 in there. Sorry, my bad. 0 in there. 97. Okay. But in our problem, we have 3 sig figs, 3 sig figs, and 3 sig figs. So our answer will only have 3, so V2 is going to be equal to 144. And our label on that is milliliters from right there. Okay, take a couple of seconds, make sure that makes sense to you. Alright, let's try the next problem. If you feel like you understand it, that's cool. You can roll on and call it good for these notes. If you want to do the second example with me, you're welcome to stay. Okay, so flipping back to my red here, it says the pressure exerted on a 240 milliliter sample of hydrogen gas at a constant temperature is increased from 0.428 atms to 0.724 atms. What will the final volume of the sample be? So, now this one gets a little confusing, and this is kind of why I put it on here. We've got 240 milliliters. That's not a pressure. That is a volume. Milliliters is a volume. So I'm going to put V1 right here is 240 milliliters. And it says the pressure, so that pressure is right here. So P1 is 0.428 atms. Everybody see where I got that? Okay. The only other number we have here is this other atms. So we said that one was P1. This one is P2. So P2 is 0.724 atm. And so we're looking for the final volume, or V2. V2 is our question mark. And all that's left is to just plug it in. We know our formula is P1V1 equals P2V2. And so we're just going to plug it in. 0.428 times 240 is equal to 0.724 times V2, which is what we're looking for. So again, just like last time, we're going to isolate V2 by dividing each side by 0.724. And we will be at our answer. So we're going to take 0.428 times 240 divided by 0.724. Scroll this up just a little bit. We get 141.878, some other numbers. But our answer should have 3 sig figs because there are 3 in each of those. So our answer is 142 milliliters. And it's milliliters because milliliters came from that right there. And these two are the same. Alright, I hope that makes sense. Thanks.